Okay, doing some more problem solving. So far we haven't learned anything else new than all the stuff that we've been seeing above there and learning how to deal with log base 10. But if we have a problem like this, and of course, we don't really have any way of trying to combine both sides here. So there's nothing that I can really do to make this a 5 and this a 5. Remember, when we're solving these types of problems, I could have, 5 to some number equals 5 to some other number, and then I can set those two equal to each other. But that's impossible because of the 120, right? Because the 120 isn't or 5 is a factor, but I can't do 5 to some power to get 120. So I'm going to have to do something else. So here's what I have to do. I have to take the log of both sides. So what I would do is I would take the log of 5 to the 4x minus 2, and that equals the log of 120, which I believe we just did above. And then what I would do is remember that there's a rule here that says this power comes in front. So I have 4x minus 2 times the log 5 equals the log of 120. Okay, I'm trying to get x by itself. So to get x by itself, I'm going to divide both sides by log 5. Now, some people have tried to cancel this log or try to cancel these numbers. Can't do that. Okay, because remember, it's log 125 is one thing. It's one number. And so I can't do that. But log 5 I can get rid of. So then I have 4x minus 2 equals log 120 over log 5. I can figure out that number. So log 120 over log 5. We're going to go back over to Desmos. So I have log 120. So notice I have it up there. So I just do log 120 divided by log 5. I get 2.975, 2.975. I'm just trying to remember it, 2.975. So then I have in this problem 4x minus 2 equals 2.975 or 795. I can't remember. 2.975. And so I have the 975 there, which is correct. Perfect. Just want to check it again. I'm surprised I got it on the first round. And so that's what we have in that particular case. Now I'm going to add 2 to both sides. So I get 4x equals 4.975. I then divide both sides by 4. So I get x equals 4.975 divided by 4, or whatever that number is that I have up there on Desmos. I can just divide this one by 4. By notice, I can just put another division here, which is nice with Desmos. So divided by 4, and I get 0.744. Okay, so that means x equals 0.744. So that would be my answer for x. Okay, now we're going to look at the change of base formula. So the change of base formula says that if I have the log a of n equals log b of n over the log b of a, this is how I would solve it. So notice that I can do something like that. I'm just going to make up some numbers. So if I say log base 3 of 5, that's going to equal the log 5 over log 3. It's also going to equal natural log of 5 over natural log of 3, because both of these, this first one is log 10 over log 10, right? It doesn't really matter which one I use. This one's log e over log e. So that would be my change of base formula. So now I want to solve this problem. Log base 2 of 50, that equals log of 50 over the log of 2. And so, but remember, it also equals the natural log of 50 over the natural log of 2, because it doesn't matter which log, as long as these two logarithms are the same. So if I go back, log of 50 over log 2, and type it in, so I have the log of 50 divided by the log of 2. And notice I get 5.644. But notice if I do the natural log of 50 divided by the natural log of 2, I get the exact same number. So 5.644. So 5.644, and that would be my answer when I do that. So it's pretty straightforward to kind of do that type of conversion. So I can get that conversion pretty easily. And we'll go on to the next video for the last of this this lesson in this